Once you're established at altitude on the en route portion of your flight, the minimum en route altitude on the airway gives you navigation and obstruction clearance guarantees. But how do you get from the airport to there? What route and altitude should you fly between your takeoff and that en route MEA? Well, if you're departing an airport with a control tower, you'll often get radar vectors to join your filed route. In that case, ATC will be giving you the headings and altitudes to fly and will be providing you with obstruction clearance. But if you're not radar vectored, what happens then? Well, in many cases, the FAA doesn't care how you depart the airport as long as you proceed to the first fix in your clearance and climb at a rate of at least 200 feet per nautical mile. Let's take a look at this little graphic. If you go 3 nautical miles at 200 feet per nautical miles, you will have gained 600 feet. And that's because they've checked and there are no obstacles that penetrate that minimum climb gradient from your departure airport, and they also don't have any traffic flow concerns. You would find this situation at a typical flatland airport away from larger cities. But what if there are obstacles or ATC has a heavy traffic load in that area? Well, you'll be glad to know that for those occasions, the FAA has a procedure for you to follow when departing IFR. And for some strange reason, they call them departure procedures, or DPs for short. You'll find DPs published in 2 ways. One is in a graphic form like a small en route chart with routes, altitudes, and a description telling you where to fly. And we'll examine these a little later. The other is a textual description of what route and altitude to fly. For instance, here at Ord, Nebraska, if you take off from runway 13 or 17, you would climb using the runway heading to 3,000 before turning. And if you're using runway 31, you climb at a heading of 325 degrees to 2,800 before turning. Now, let's take a closer look at when and how the FAA designs departure procedures. First of all, departure procedures apply for airports that have instrument approaches. When the FAA designs an instrument approach for an airport, they also look to see how aircraft should depart it. If airplanes can turn in any direction after taking off from a runway and still clear all the obstacles, then the FAA won't publish a DP unless it's needed for air traffic purposes. But if there are obstructions that stick up into the departure area around the airport, then the FAA will do one or more of the following. It will increase the required climb gradient. It may increase the standard takeoff minimums to allow you to remain clear of obstacles visually, or design and publish a specific departure route. Now, the FAA has set some ground rules for clearing obstacles during an instrument departure. They expect you to be at least 35 feet AGL at the end of the departure runway. Climb to 400 feet above the airport elevation before turning, and climb at least 200 feet per nautical mile. But as we've said, a DP may require you to climb at a higher gradient for obstacle or ATC purposes. So, using a DP solves your problem of avoiding obstacles between takeoff and the en route structure, and it may also solve an ATC traffic flow problem at busier airports. Since you're guaranteed obstacle clearance, if you use a DP, it's a really good idea to file and fly the published DP for all departures at night or when you have a marginal VFR weather situation or worse. But what if your departure airport doesn't have a DP, or you choose not to use the one published? Well, then you're responsible for your own obstacle clearance after takeoff. Now, just what kind of minimum weather conditions would you want for IFR takeoffs? Well, for commercial operators, the FAA has a standard visibility minimum for takeoff of 1 statute mile that applies to both single and twin-engine airplanes. And at some airports, because of obstacles, they publish non-standard higher visibilities and may even include minimum ceilings for your takeoff. If an airport or runway has either a departure procedure or non-standard takeoff minimums, on the NOS approach charts, you'll see a T in a black triangle telling you that you can look up the departure procedure or non-standard minimums in the front of the book. Now, the JEP charts just spell out the takeoff minimums on the chart itself. As a private non-commercial operation, the FAA regulations allow you to take off with 0 ceiling and 0 visibility if you want to. Personally, folks, I wouldn't want to. And actually, it's a very good idea to observe those commercial takeoff minimums or even set your own higher personal minimums. That way, you'll always have a margin before you transition into instrument conditions. And you'll also have more visibility for an instrument approach back into the airport in case you have a problem that you didn't anticipate after takeoff and need to return for landing. Now, as we said earlier, if ATC is giving you radar vectors, they are also guaranteeing you obstruction clearance. But this obstruction clearance does not start just because the controller says radar contact. That only means that the controller has identified you on his radar screen. ATC does not assume responsibility for giving you obstacle clearance until the controller has taken control of your navigation by giving you an assigned heading to fly. But even then, you should be aware of the obstruction heights in the area in which you're flying. And that's one very good reason to have your VFR charts available even when you're departing for an IFR flight. Studying the local VFR chart during your pre-flight planning will make sure you know what kind of terrain and obstacles you have around your departure airport. What you learn from those charts may well be a lifesaver if things don't go exactly as planned after takeoff. So now you know that IFR departure procedures guarantee you a safe transition from airport to en route flight, provided your airplane can climb 200 feet per nautical mile. That guarantee is the best reason I know to use one on every IFR departure.